A welder used a rectangular sheet with dimensions 5 meters by 3 meters to make an open rectangular box by removing equal squares of side A meters from each corner of the sheet. I show that the volume V in meter cube of the box is given by V equals 4A cubed minus 16A squared plus 15A. And then the second part is find correct to the nearest whole number, the maximum possible volume of the box. Then the last part, find the equation of the tangent to the curve y equals 9x minus x cubed at the point where x is equal to 1. So this B part is unrelated to the first part of the question. So let's make some sketch. Let me sketch a rectangular box, a rectangular sheet somewhere here. So let's assume this is our rectangular sheet. The question says that he removes squares of side A meters, and we know that a square has equal sides. So it means that if you remove this from this corner, you remove A here and A here. Then we reference to this corner, here's A, here's A. Then we reference to this corner, this is A, this is A. And then we reference to this corner to this is A and this is A. Please, this has not been drawn to scale. It's just a mere sketch. But from the question, the length is 5 meters. And then the breadth is 3 meters. So if you remove A meters from here, A meters from here, what is the remaining length from this side to this portion? So it's going to be A plus A is 2A. So you remove 2A from 5 meters. So this part will be 5 minus 2A. And what about this side, which is 3 meters? What will be left? You remove 2A from that side. So it will be left with 3 minus 2A. So since you remove A meters of squares, the volume of a square is A cubed. So it means that the height of this rectangular box is A meters. So each height is equal to A meters. So from this point, we are in a good position to find the volume. Volume of a rectangular box is the length times the breadth times the height. That is the equation of the volume. So it means that the volume is equal to the length, which is 5 minus 2A in one bracket, times the breadth, which is 3 minus 2A, then times the height, which is A. So let's then go ahead and then solve. V is equal to, we are distributing 5 times 3 minus 2A, then minus 2A, 3 minus 2A, all of this times A. So we add volume as V equals into bracket 5 times 3 minus 2A, then minus 2A times 3 minus 2A, all times A. So V is equal to, now what is 5 times 3? It is 15. 5 times minus 2A is minus 10A. Minus 2A times 3 is minus 6A. Then minus 2A times minus 2A equals plus 4A squared. All of that times A. So V is equal to 15. Then minus 10A minus 6A is minus 16A plus 4A squared times A. So V is equal to, multiply through by A, you get 4A squared, 4A cubed, because 4A squared times A is 4A cubed. Then minus 16A times A is minus 16A squared. Then plus 15 times A is plus 15A. So this was exactly what we were supposed to prove from the question. The second part says we should find correct to the nearest whole number, the maximum possible volume of the box. So the maximum volume, what is the maximum volume? So at the maximum volume, Vn prime of A is equal to 0. So let's find Vn prime of A, which is just to differentiate Vn. So Vn prime of A is equal to, if you differentiate for A cubed, you get 12A squared. And if you differentiate minus 16A squared, you get minus 32A. And if you differentiate 15A, you get plus 15. So this is Vn prime of A. But because we are looking for maximum volume, we will then take this equation and equate it to 0. So we are going to get 12A squared minus 32A plus 15 is equal to 0. So you see that this equation is of the form ax squared plus bx plus c is equal to 0. This a squared, this a and this a are not the same. It is just a mere coincidence. So I'll differentiate one of the a by putting just an asterisk here to differentiate this a from this a. So we see that a asterisk is equal to 12, and then b equals minus 32, and then c is equal to 15. So let's use the quadratic formula to find the value of a. A is equal to minus b plus or minus square root of b squared minus 4. In this case, it will be a asterisk times c, all divided by 2a asterisk. So a is equal to minus b, which is minus minus 12. Minus minus 12 is 12, plus or minus b squared, so minus 12. I made a mistake. A is 12, but b is minus 32. B is minus 32. So A is 12, B is minus 32, and then C is 15. So in this case, minus B is minus minus 32. So yes, supposed to be plus 32. Then plus or minus square root of B squared, and B is minus 32 squared minus 4 times A is 12, times C is 15, all divided by 2 times A is 12. So if you carry on, you find that A is equal to 32 plus or minus square root of minus B, minus 32 squared is 1024 minus 4 times 12 times 15 is 720 divided by 2 times 12, which is 20. 2 times 12 is 24. So A, the values of A are A equals 0.61 or A equals 2.06. In the values of A, which of these values will give us the maximum volume? We will not be able to tell until we find the second derivative of Vn, which is Vn prime prime of A. And we know that if Vn prime prime of A is less than 0, that one will give us the maximum volume. And if so, the maximum volume occurs at Vn prime prime of A less than 0. And then Vn prime prime of A greater than 0, we will have the minimum volume occurring at that point. So let's find Vn prime prime of A. What is Vn prime prime of A? We then take Vn prime of A and further differentiate it. If you differentiate 12a squared, you will get 24a. If you differentiate minus 32a, you get minus 32. If you differentiate 15, you get 0. So v prime prime of a is 24a minus 32. So let's go ahead and find v prime prime of. We take this point and dump it and insert it in this equation and see which of them will give us the maximum volume. So v prime prime of 0.61 equals 24 times 0.61 minus 32. And this is equal to minus 17.36. Then v prime prime of 2.06 is equal to 24 times 2.06 minus 32, and that is equal to 16.72. And you see that 16.72 is greater than 0. So this is less than 0. It means that this implies that it is the point x equals 0.61 that will give the maximum volume. So maximum V. So what we need to do is to take 0.61 and put it back into the original equation of V to find the maximum volume. So V is giving us 4a cubed minus 16a squared plus 15a. We are finding V of 0.61, and this is equal to 4 times 0.61 cubed minus 16 times 0.61 squared plus 15 times 0.61. And this is equal to 4.1043. But the question says that we should find it correct to the nearest whole number. So this is equal to 4 meter cubed. Now, the second part of the equation says we should find the equation of the tangent to the curve. So the curve is y equals 9x minus x cubed at the point where x is equal to 1. So let's just put x equals 1 here and find the y component. So y of 1 is equal to 9 times 1 minus 1 cubed. 9 times 1 is 9 minus 1 cubed is 1. So y equals 8. And therefore the point at which the tangent touches the curve is 1 and 8. So let's go ahead and find the gradient. I will know that the gradient m is equal to dy dx, which can also be written as y prime of x. But we're given the curve y as 9x minus x cubed. So what is y prime of x? Is equal to, if you differentiate 9x, you get 9. Minus, if you differentiate 3x cubed, you get 3x squared. So the point is x equals 1. So let's then find y prime of 1. This is equal to 9 minus 3 times 1 squared. And this is equal to 9 minus 1 squared is 1 times 3 is 3. 9 minus 3 is 6. So this implies that the gradient m is equal to 6. Equation of a line is given as y minus y1 equals m times x minus x1. So y minus y1, and then we have the y component as 8 equals m. The gradient is 6 times x minus x1. x1 is 1. So let's go ahead and distribute this. So y minus 8 is equal to 6 times x, 6x. 6 times minus 1 is minus 6. I want to take everything to the left hand side of the equation. So y minus 8 minus 6x plus 6 is equal to 0. So the final answer is y minus 6x. Then minus 8 plus 6 is minus 2 is equal to 0. A function is defined on the set R of real numbers by f is said that x maps to 2 over 3x cubed minus 5 over 2x squared minus 3x plus 1 over 6. Determine the values of x for which f is increasing. So we know that the values of x for which f is increasing is when f prime of x is greater than 0. So our first task is to find f prime of x is equal to, but this is f of x. So let's differentiate this function. So it will give us 3 times 2 over 3x squared minus 2 times 5 over 2x minus 3. So this 3 and this 3 can cancel out. These 2 and these 2 can cancel out. And therefore f prime of x is equal to 2x squared minus 5x minus 3. So, but we've already said that the values of x for which f is increasing is the values of x for which f prime of x is greater than 0. So we need to set f prime of x greater than 0. This implies that 2x squared minus 5x minus 3 is greater than 0. So you see that 2 times minus 3 is minus 6. You need to find two numbers that when you multiply you get minus 6, but when you add you get minus 5. Those numbers are minus 6 and 1. So this can further be written as 2x squared minus 6x plus x minus 3 is greater than 0. So let's factorize 2x from this side. You get x minus 3 in one bracket, then plus 1 in another bracket. You get x minus 3 is greater than 0. So in one bracket you get 2x plus 1 times in another bracket x minus 3 is greater than 0. So the values of x are x equals minus 1 over 2 and x equals 3. So these are the values of x that we got. Let's then go ahead and then plot these values on a number line. So assuming this is our number line, 0 is here, and we have minus 1 over 2 and then 3. It is not equal to. X is greater than minus 1 over 2 and x is greater than 3. So since it is greater than, then we need to use open circles. So let's test this region. Let's pick a value between minus 1 over 2 and 3. Let's assume that 0. 2 times 0 is 0. 0 plus 1 is 1. 0 minus 3 is minus 3. 1 times minus 3 is equal to minus 3. But minus 3 is not greater than 0. And therefore this region is not part of the solution. Let's take values below minus 1 over 2 like minus 1. 2 times minus 1 is minus 2. Minus 2 plus 1 is minus 1. Minus 1 minus 3 is minus 4. So minus 1 times minus 4 is 4, and 4 is greater than 0. So this region is one of the required regions. Let's take values greater than 3, for example 4. 2 times 4 is 8. 8 plus 1 is 9. Then 2 minus 4. 4 minus 3 is 1. And 1 times 9 is 9. And 9 is greater than 0. So this region too is a required region. And at the end of the day, this is going to go in this side. So we have x less than minus 1 over 2 and the values x greater than 3. These are the values of x for which f of x is increasing. The equation of the tangent to the curve y equals 1 over x at the point where x is equal to 2. So let's find the y component. Y is equal to 1 over x. So let's find y of 2. It's equal to 1 over 2. So the point where the tangent touches the curve is x2 and then 1 over 2. So let's go ahead and find y prime, which is equal to m. The gradient m is equal to y prime of x. So let's find y prime of x. Y of x is equal to 1 over x. So we need to use quotient rule in this case. For example, if f of x is equal to u of x, then divided by v of x, the rule says that f prime of x is equal to, bring v of x here and then differentiate u of x, then subtract it from, differentiate v of x and then keep u of x and divide it by the square of v of x. So let's use that to find y prime. So what is y prime of x? This is equal to, keep v of x in this case is x, and differentiate u of x. You differentiate 1 is 0, minus, keep, differentiate v of x. If you differentiate x is 1 times, keep u of x is 1, divided by the square of v of x, so x squared, and this is equal to, x times 0 is 0, 0 minus 1 times 1 is 1, minus 1, divided by x squared. So this is y prime of x. But then the point is x equals 2. So let's find y prime of 2. This is 1 minus 1 over 2 squared, which is equal to minus 1 over 4. So we have the gradient m to be equal to minus 1 over 4. And we have this point. So let me find the equation somewhere here. Y minus y1 is equal to m times x minus x1. So y minus, what is y1? Y1 is 1 over 2 equals m is minus 1 over 4 times x minus x1. x1 is 2. So let's multiply 2 by 4. 4 times y is 4y, minus 4 times 1 over 2 is 2. It's equal to minus 1 over 2. 4 times 4 is minus 1 times x minus 2. So this is 4y minus 2 equals minus 1 times x is minus x. Minus 1 times minus 2 is plus 2. So we are going to take all of these times to the left hand side. So we'll get 4y plus x minus 2 equals 0. So the final answer is 4y plus x minus 4 is equal to 0. The gradient function of y equals px squared plus qx plus r is 8x plus 4. The function has a minimum value of 1. Find the values of p, q, r. And then b, find the value of c for which y equals 3x plus c is perpendicular to the tangent of y equals x squared minus 1. So the y is giving us y equals px squared plus qx plus r. So this is y. Then the question is saying that the gradient of this is equal to 8x plus 4. So let's find y prime of x. It's equal to 2px plus q. And then this, the question says, is equal to 8x plus 4. So in other words, 2px plus q is equal to 8x plus 4. So right from here, you see that the coefficient of x here is 8. The coefficient of x here is 2p. So it implies that 2p is equal to 8. And if we divide through by 2, you see that p is equal to 4. And q in this case is also equal to 4. So we are left with r. But the question says that the function has a minimum value of 1. So it means that we should take this y prime of x and equate it to 0. Then we can find the minimum value, which is x. So y prime of x is 2px plus q equals 0. So let's make x the subject. X is equal to minus q over 2p. But we know the values of minus q, of q and p. So this is minus q is 4 divided by 2 times 4 because p is 4. And therefore x is equal to minus 1 over 2. So let's then take this x equals minus 1 over 2 and put it back into the original equation. But from what we found so far, we see that y of x is p. P is 4x squared. Then q is 4x, so plus 4x, then plus r, which we don't know yet. So let's find y of minus 1 over 2. This is equal to 4 times minus 1 over 2 squared plus 4 times minus 1 over 2 plus r. So y of minus 1 over 2 equals 4 times minus 1 over 2 squared is 1 over 4 plus this and this will cancel. So we'll be left with 2 here. So minus 2 plus r. So this is equal to 4 and 4 cancel. 1 minus 2 is minus 1. So it is r minus 1. So y of minus 1 over 2 equals r minus 1. And that is the minimum value. But he says that this minimum value is 1. So we just have to say r minus 1 is equal to 1. So r is equal to 1 plus 1, which is 2. So the function y is equal to 4x squared plus 4x plus 2. Then the second part, find the value of c for which y equals 3x plus c is perpendicular to the tangent of y equals x squared minus 1. So the equations of the line were given. Y1 is 3x plus c. Then y2 is equal to x squared minus 1. So he says that we should find this value of c because this line is perpendicular to this. So let's take this line, y1 equals 3x plus c. What is the gradient m1? It is just 3. So let's find the gradient of m2 from this gradient of m1. But the question says they are perpendicular. So since they are perpendicular, their product m1 times m2 should give minus 1. So m1 is 3 times m2 is equal to minus 1. So m2 is equal to minus 1 over 3. So the gradient of m2 is minus 1 over 3. So y2 is equal to x squared minus 1. So let's find the gradient m2 from this equation too. But then we need to first find y prime of 2. So y prime is equal to, if you differentiate x squared, you get 2x. If you differentiate minus 1 is 0. So y prime of 2 is 2x. So the gradient of 2, the gradient m2 from the first equation is minus 1 over 3. And the gradient m2 from the second equation is 2x. So we can equate the two. So at this point, m m2 equals m2, so this implies that, so let me use this implies that 2x is equal to minus 1 over 3, and therefore x is equal to minus 1 over 6. So having found the value of x, let's then put it in the first equation to find the value of c. So y1 of x, and x is minus 1 over 6, is equal to 3x, which is 3 times minus 1 over 6 plus c, and this is equal to minus 1 over 2 plus c. So y1 of minus 1 over 6 is equal to c minus 1 over 2. Let's find y2 of minus 1 over 6, and this is equal to, we put it in this, which is minus 1 over 6 squared minus 1. Minus 1 over 6 squared is 1 over 36 minus 1. And 1 over 36 minus 1 is minus 35 over 36. So we can then equate y1 and y2. So y1 equals y2. What do we get? This means that c minus 1 over 2 is equal to minus 35 over 36. So c is equal to minus 35 over 36 plus 1 over 2. So how do we solve this? So let's multiply the numerator and the denominator of 1 over 2 by 18. So c is equal to minus 35 over 36 plus 1 over 2 times 18 over 18. So c is equal to minus 35 over 36, then plus 1 times 18 is 18 over 2 times 18 is 36. So c is equal to minus 35 plus 18 is minus 17 divided by 36. So that is the value of c. The radius of a circle is 12 centimeters. Find, leaving the answer in terms of pi, the rate at which the area is increasing when the radius is increasing at the rate of 0.2 centimeters per second. So the radius is increasing at 0.2 centimeters per second. It means that dr dt is equal to 0.2 centimeters per second. But we are supposed to find the rate at which the area is increasing. So we want dA dt. So let's write a formula that links dA dt and then dr dt. So dA dt is equal to dA dr times dr dt, so that dr and dr can cancel and we get back dA dt. But we have been given dr dt in the question, so we need to find dA dr. But then we know that area of a circle is given as pi r squared. So area is equal to pi r squared. Let us find dA dr from here. So dA dr is equal to 2 pi r. So having found dA dr, we can then insert it into this equation to find dA dt. So dA dt is equal to dA dr, which is 2 pi r, then times dr dt. Dr dt was given as 0.2 centimeters, so times 0.2. So dA dt equals 2 pi, but the radius of the circle was given as 12 centimeters, so times 12 times 0.2. And then the question said we should leave it in terms of pi. So dA dt is equal to 4.8 pi centimeter squared per seconds.